Yeah?
Yeah.
Okay, welcome, Wharton Wildcats. Mr. Bell's Wildcat Math class. We're doing the Algebra 2 review for Semester 2. Starting on number 1. So it says, determine if the following functions are examples of exponential growth or decay. So remember, these have the form a times b to the x power. So what determines whether it's growth or decay? The b value, right?
Yeah.
The number being raised to the power. Okay, so if it's greater than 1, it's growth. Good. So in this case, our b value is between 0 and 1, so it's decay. Does a negative have anything to do with it?
No.
Not this question, right? What about that b value? Growth? Growth, right? Yes, sir.
What happens if the b value is equal to 1? Is that the growth?
It would not be exponential.
Okay.
Yeah, to be exponential, the b value can't be equal to 1.
Okay.
All right, any questions on number 1? Hopefully there'll be a couple of those on the exam, yeah?
Yeah, hopefully.
A
Hopefully.
Every question?
You have a question?
No, I said every question should be like that on the
All right, number 2. So once you graph this exponential growth equation, y equals 2 to the x power, state the domain of range. So let's do some points. What's 2 to the negative 1 power? 1/2, very good. 2 to the 0 power? 1. 2 to the first power? 2. How about 2 squared? I think we can see what this is going to look like. Okay. What's our domain? How far left and how far right does this thing go? All real numbers? So maybe it'll be negative infinity to infinity. What about the range? How low and how high? You could do y is greater than 0. Do 0 to infinity. Just make sure you don't include 0. And we have what kind of asymptote? We got a horizontal asymptote. And it'll be y equals 0. Any questions on that?
Wait, can there ever be more than one horizontal?
Yes.
How'd you get the horizontal asymptote?
No matter what I make this x,
Yeah.
the y can never be 0.
Oh,
I mean, it'll get closer and closer. Like if I made, say, -2 for my x, that'd be 1/4 for the y. So the y is going to keep getting smaller and smaller and smaller, but it'll never reach 0. Okay? All right, graph y equals log base 2 of x, and set the domain and range. So we can use our calculator on these. How do we plug this in our calculator to graph it?
that's the y,
Go to y equals, right?
but, yeah.
Some of you got the new calculators where you can already change the base, right? Some of us had the older calculators where the calculator only does base 10, right? So how about we plug that in our calculator if we wanted to do, if we have the older calculator?
Remember that? I'm used to having a use button.
Use the handy dandy.
Actually, it's the inverted button.
So if I were to plug this in the older calculator, I'd have to change the base formula, log of x over log of 2. And make sure you put parentheses. That'll help. Notice the x is higher on the paper than the 2 is. So when you do change your base, keep it that way. The x goes up top, the 2 goes to the bottom. Okay? So if you plug that in your calculator, you're probably going to get something like something like that. Is that pretty close? Okay. So what would the domain be? How far left, how far right?
X is greater than 0.
X is greater than 0. So you could say 0 to infinity, not including the 0. How about the range? All real numbers. And any asymptotes?
X equals,
Is that a vertical asymptote? X equals 0. We're good? Number 4, given the parent function f of x equals 5 to the x power, describe the transformations. So we've got 2 transformations in A, 4A. What's the negative in the front going to do? Reflect across the x-axis.
Move left.
And I'm adding 2 with the x, so that'll be left 2. Good. Part B, we got 2 transformations again. We're going right 4 and down 1. Any questions on the transformations? All right. And 5, given the parent function y equals log base 6 of x, describe the transformations. So on A, we've got 2 of them. What's the 3 in the front going to do?
like either this direction or
Vertically stretch.
Vertical. Stretch. By 3. And plus 4 at the end is going to go go up 4. And then 5B, we've got another reflect across x-axis.
And it goes right one. I what?
And it's going to be right 1. Any questions on 1 through 5? Yes, sir.
For A, the 3, how did you know it was a vertical stretch and not the other one?
What's the other one?
Horizontal stretch?
Okay, so if it's in the front, it's vertical.
Yeah.
If it's in front of the, right, if they would have put it right here in front of the X, that'd be horizontal. Okay? Yes?
Does it matter that it's log 6?
Mr. Bell.
Well, yeah, some, yeah. So the parent function is log base 6, so that doesn't change.
Okay, so that just, give me log of 6.
Well, they're telling us that we're comparing it to this, so the 6 didn't change. Does that make sense? If basically it says what happens to this if we do these things to it. Well, the 6 didn't change anything. Okay?
Are you recording it for the?
Like, where you have to